Good morning, dear students. Today we are starting our section with the another head, that is classification of eukaryotic chromosome. How we can classify the eukaryotic chromosome? It is purely based on the position of centromere, where the centromere is located. Based on that, we are classifying the eukaryotic chromosome. You can go and see one by one. First is Ascendri Chromosome. Ascendri Chromosome means, A means absent. What is absent here? Centromere is absent in this type of chromosome. We have learned in the last class that centromere is very important to hold the two sister chromatids together and also for its equal distribution to the daughter cell during the time of cell division, during mitosis. Okay, as that centromere is absent in this type of chromosome, it may lead to uneven distribution of chromosome among the daughter cell. That is the condition. Such type of chromosome also exists in the case of eukaryotes. Then next type, metacentric. Metacentric chromosome is like this, this way. And what is its nature? Upon observation, what you can feel here, the two arms are of equal length. That means centromere is located in the middle of the chromosome. So that's why arms are equal in length. And as you will learn the mitosis, I already told you that mitosis have different stages, and one of its stage is called anaphase. And what is happening in that anaphase? In anaphase, the already replicated chromosome move to opposite poles. That is the main process that is happening in anaphase. In the case of metacentric chromosome, as it moves to the pole, what will be its appearance? As something is pulling it to one pole, it will have the appearance like this way, a V-shape. V-shape appearance it attains during the anaphase of mitosis. Which type of chromosome? Metacentric chromosome. Okay. I hope that you understand what is metacentric chromosome. Which are the points? In this type, both arms are equal in length, approximately equal in length. Centromere is at the middle, and it attains a V shape during the anaphase of mitosis. Okay. Next, submetacentric chromosome. Submetacentric chromosome, look, what is the difference when compared with the metacentric? Here, the position of the centromere is off-center. Off-center means it is somewhat located away from the correct exact central position. That is submetacentric. And what would be its shape during the anaphase stage? This chromosome attains J shape because the centromere is moved more towards one end. That's why as it pulls as this chromosome is pulled to one pole, it attains a J shape. It attains a J shape. The next is acrocentric. Acrocentric chromosome, look what is the difference in appearance. Here the centromere is more towards the end of the chromosome, very close to one end, and the other end only have that telomeric portion and only a little other portion. That much the centromere move to one end in the case of acrocentric chromosome. As it moves this much, as the centromere moves this much to one end, it attains what shape? I shape during the anaphase, while it get pulled to any of the poles. that is acrocentric. Then coming to telocentric chromosome. Telocentric, in that case, the centromere is positioned the extreme tip of the chromosome, in the terminal portion of the chromosome, and it appears rod-shaped during the time of anaphase. It's about the classification of eukaryotic chromosome. Next, we are moving to another section, that is giant chromosome. Giant, the term itself means that it is very big. And what is giant chromosome? They are enlarged, modified chromosomes where we can found in the salivary gland cells of diphtheran larvae. Diphtheran larvae. Diphthera means it includes flies. Flies all come under this diphtheran. And in diphtheran larvae, salivary gland contain this type of giant chromosome. Or in the case of amphibians, oocyte, amphibians egg also contain this giant chromosome. Okay. The giant chromosome are of two types, which are the polythene chromosome and Lambrush chromosome. First, we are going to understand about polythene chromosome. These are the images of different diphterans. Okay, first one, polythene chromosome. It is discovered by E.G. Balbiani, where he observed this type of chromosome in salivary gland cells of diphtheran larva, Chironomus. Its picture is shown here. And in addition to the salivary gland cells, where all these giant polythene chromosomes are located in the gut epithelium. Gut means the digestive tract epithelium. The fat body cell. Fat body cells are the nutritive cell that is found in the body of insects. It's a type of tissue. So, and also in Malpighian tubules. Malpighian tubules are involved with excretion. Then in ovarian nerve cells means the nerve cells, nurturing cells meant for the ovaries. In all these structures, all these parts also, it is possible to locate a polythene chromosome. Then how this polythene chromosome is forming due to repeated DNA replication without separation. I hope that in a basic level you all know what is DNA replication. So DNA replication is happening, but that replicated DNA is not separating to different cells, daughter cells. So by that way, the number of arms is increasing in one cell itself. By that way, polythene chromosome is forming. And we need to understand about another term, that is DNA content. For that, first I am showing the picture of this chromosome. What is the DNA content of this chromosome? Yes, 2C. How we understand what is the DNA content? By counting the number of arms. So this chromosome, its DNA content is 2C. As it undergoes replication, it attains this form, and at that stage, what is its DNA content? 4C, because 4 arms are there. Then another term, chromocenter. What is chromocenter? Here is the centromere of the polythene chromosome, and around that centromere present an aggregate of heterochromatic DNA. Heterochromatic DNA, we know what is that. It's a highly condensed DNA portion. So that highly condensed DNA portion, that is heterochromatic portion that's seen around near to the centromere, is called the chromocenter. Is it clear? What is chromocenter? Okay. Then from that chromocenter, the arms of the polythene chromosome is emanating. In Drosophila, 4 pairs of chromosome are present, and among the 4, the second and the third chromosome are the largest one. Okay, next we need to understand about dark and light bands. If we take one arm of a polythene chromosome, we can see so many dark and light bands. What is that dark and light bands? It's very simple. Dark banded regions are the region of heterochromatin and light bands are the region of euchromatin. Heterochromatin is the condensed DNA part and euchromatin is the not condensed, not condensed as well as extended part of the DNA. So that's what the dark and light bands. While we are applying acetocarmine stain on this polythene chromosome, acetocarmine is a stain meant for staining DNA, and that we can see that heterochromatic and euchromatic region as dark and light bands. Then another term, chromosome puffs. All these points you need to write while such a question came for your examination mode, polythene chromosome. What is chromosome? What is dark and light bands? What is chromosome puffs? What is DNA content? What is chromocenter? All these points you need to add. Okay. Next, chromosome puff. What is puff? Puffs means something is extruding out from the main axis. What is extruding? The DNA itself, that chromosome part itself. Why it is extruding? Because we already have learned that for undergoing transcription, the condensed DNA need to extend. That extension leads to the extrusion of that chromosome from the main axis. That extruded portion are called chromosome puffs. And what is Balbiani rings? Balbiani rings are these enlarged puffs. They are called Balbiani rings. And that puffing is induced by a hormone. What is the name of that hormone? It is ecdysone. Because of the influence of this hormone, that puffing is happening. Next, we need to understand about another process, that is endomitosis. It's also very important. What is endomitosis? It is a phenomenon in which chromosome undergoes replication and doubling, but nuclear division is not happening. And as a result, what will ends up? It may lead to the formation of a cell with a more number of chromosome. That be the end result of endomitosis, because that chromosome only double, but the nucleus doesn't divide. So that is endomitosis, and it may lead to polyploid condition. Diploid, we know that 2n means in the case of ours two set of chromosome are present in a single cell. We have 23 pairs. It is 2n. And in the case of endomitosis, that 2n become 3n, 4n, or like that. That means the content of the chromosome doubles, but the nuclear division is not happening. That is endomitosis. Okay. Then we are moving to another section, that is Lambrush chromosome. What is Lambrush chromosome? Lambrush chromosome, it occurs in the primary oocytes of some invertebrates and also in all vertebrates. When it occurs during the diplotin is a stage in meiosis. Meiosis, you will learn later. In that division process, there is a stage diplotin. During that diplotin stage, I will write what is diplotin. Diplotin stage. Diplotin stage, we can see this Lambrush chromosome. It is discovered by Fleming in 1882 and is named by Ruckert. What are its features? They are bivalent chromosome itself. But what is happening? There is the two sister chromatids are also normally present here, but the only difference is that each chromosome, if we take the case of each chromosome, it all possesses a central axis. We can see here a central axis is present, and from that central axis, that chromatid it loops out from the main axis. For what? To undergo gene transcription. Okay, and I hope that you understand that. What is Lambrush chromosome? Lambrush chromosome, we can observe such stage of chromosome in the diploid stage of meiosis, and during that stage the chromosome extend out in the form of loop from from the central axis for undergoing transcription. And that central axis is of tightly packed chromatin itself. The central axis means it is a tightly packed chromatin area, and that loop portion, it is the extended chromatin region to undergo transcription, and the whole structure then gives the appearance of a Lambrush. So it gained that name, Lambrush chromosome. Okay, I think you understand that. With this, we finish this nucleus chapter and today's section. Thank you.
I'm an icon, man. And my girl about a 10. I should fuck her in a Benz.